Okay, so welcome back. So now we're going to do an example of where we have an even power of sine. Okay, so in this case we want to evaluate this integral, and it's just x squared x. Okay, or sine squared x. So in this case we're not going to be able to use the Pythagorean identity because we're not going to be able to do a u substitution. Okay, and we can't integrate this directly because we just don't know what it is. Okay, so we're going to have to use some other substitution, and this is where the power reducing identities come in, because we can rewrite this as the integral of what? Well, sine squared x is equal to 1/2 times 1 minus cosine dx. Okay, so now I just rewrote it where now I have a cosine, just a regular cosine. We know how to integrate cosine, right? The only thing we have is the 2x, but we can deal with that too. That's no problem. So now, if I rewrite this term by term, so this is going to become the integral of what? It's going to be the integral of 1/2 minus 1/2 cosine 2x dx, which then we can integrate this term by term. And so the integral of just 1/2 is just going to be 1/2 x, right? So that's just going to be 1/2 x. And then the integral of this is going to be minus, well, what's the integral of cosine? The integral of cosine is sine, right? The antiderivative of cosine is sine. So we're going to get sine 2x, but then using the chain rule for integration, we have to divide by the derivative of the inside, which means we're going to have to divide by 2, which means that this 1/2 is going to become 1/4. So we get 1/4 sine 2x plus c. And that becomes our final answer. And we're done. So now, here's one for you to do. So evaluate the integral of cosine squared x. And again, it's going to be very similar to what I just did. Okay, take care. I'll see you soon.